Welcome to today's webinar entitled Benefits of Drones in Evaluating the Building Enclosure. My name is Billy Zadek, Manager of Special Programs for APA. Just a couple of housekeeping items before we get started. The webinar recording will be posted to the APA webpage under the Continuous Learning tab later today. Professional continuing education certificates are being offered for today's program. Those who indicated they wanted a certificate at registration and meet the requirements will receive certificates later this afternoon. All attendees are in listen-only mode. Please type your questions in the chat box and they will be answered in the order they are received. If we run out of time and we still have questions, responses will be sent directly to the person asking the question by one of our presenters. Before we get started, I'd like to introduce our speakers for today. Cole McCarthy is a project manager and licensed drone pilot for Gale Associates Building Enclosure Design and Consulting Group. He has extensive experience performing evaluations and designs for remediating existing building enclosure failures, including roofs, walls, windows, and structure components. Christophe Gervais is a certified drone pilot, level 1 thermographer, and senior graphics and imaging designer with deep experience in designing presentation and infographics, as well as photographic and 3D simulations. At this time, it's my pleasure to turn it over to these gentlemen for today's webinar. Gentlemen, take it away.
All right, thank you, Billy, and thank you everyone on the call who's listening in today. Christophe and I are really honored to have this opportunity to talk to everyone about a little bit about drones. And specifically, how are they going to help us to evaluate our building enclosures? Just a little bit of background before we get started. So Gale's been implementing drones now for about 6 years with a lot of our projects. And we've probably flown several hundred flights across all offices. So we feel like it's really provided a lot of benefit for not only us, but also our clients, and has just made everyone's lives a lot easier when trying to reach some of these hard to reach areas. So today we're just going to we're going to give a quick intro to drones, kind of a little bit how they work, what we use them for, and then I'll dive into some of the FAA regulations, which is just kind of what is limiting us from our flights, and then we'll jump into just some case studies, some examples where we've used the drones for evaluating the building enclosure, and just so you guys can start to think about maybe some of your own buildings. And then we'll end with just some quick, questions that we get asked a lot, either, leading up to a flight or during flights. So hopefully answers those questions if you might have the same ones. All right, so what is a drone? Technically, the drone is called a small unmanned aerial system, or SUAS. And they're actually first used technically back in the 1800s, mid 1800s. Is basically just a giant balloon with no one in it, and they're really used for military surveillance and even weapons. So you can see that photo on the top right there is a image apparently of an early age drone, but of course, now we have these movie theater quality drones with these crazy cameras that are thousands and thousands of dollars each. So, over the last decade or two, we've seen huge growth in popularity, not only for recreational use, but also commercial use as well. This is just kind of one of our typical drones diagram with the different components. I won't go through every single one of these features, but obviously you can see, the 4 propellers, obviously the high definition camera in the front, and then maybe most importantly, the sensors that are located top, bottom, and then all the way around the drone. And those are actually there to help with obstacle avoidance. So, they can actually override the pilot's commands if it thinks the drone is going to collide or crash into something. So, nice little safety feature for us. And then on the right is just one of our typical remotes. So, just like a video game, you have 2 joysticks, one to move forward, back, left, right, and another to rotate the drone 360 degrees, and then also adjust the elevation or the height of the drone. So We also have to carry, of course, batteries. These are all electronically powered drones. They do have actually gas-powered drones, but they would be much, much larger and louder. So we obviously opt for just the smaller, lightweight. They're only about 2 pounds each. And we carry the lithium-based batteries. We'll carry anywhere between 6 to 10 batteries, depending on how long we think the flight's going to last. And each battery gets us about 20 to 30 minutes of flight time usually. That can be a little less if it's really cold or windy day. But other than that, we're generally carrying, of course, the drone, a case with a bunch of batteries, chargers, remotes, and that's generally it on flight day. So this slide just shows the drone fleet that we at Gale have specifically. I'm sure other drone service providers have similar drones at least for evaluating the building enclosure. You can see a lot of them are manufactured by a company called DJI, and they all generally have the ability to take photo and video. One interesting feature about our DJI Mavic 2 Enterprise Advanced, which is the drone on the top right, it's actually fitted with an infrared camera. So we can take infrared images, we can scan roofs, walls, windows for air leakage or water leakage or things like that. So Christoph will get into that a little bit more later on. But then we also have our Skydio 2 Plus, which is in the bottom right. And this drone can actually do 3D scanning and 3D mapping. So, if you want to make a 3D model of your building or a part of your building or even your whole campus, it can do that in several different phases. So pretty neat. And then, these are just kind of some of the popular drone services that may be out there that you could request. So of course, aerial photography is the no-brainer. I would like to highlight the facade condition studies and roof evaluations. And that kind of relates more to what we're talking about today. Those are also probably our 2 most commonly requested services, at least for our drones. And then, of course, that kind of goes hand in hand with structure inspections or storm damage assessments. And then, as I said before, our aerial thermography with the infrared camera. We also can do 3D mapping and then laser scanning for as-built. So you can actually plop it right into a Revit model or some similar type of software. So pretty great. The technology has really come a long way in the last 10 or 20 years. So without drones, of course, or before the time of drones, we had other methods, but they were a little more dangerous or it could be time consuming and definitely expensive. So the obvious one would just be, you could see the building facade from the ground using binoculars or a high-powered camera. This isn't necessarily dangerous or super expensive, but it is time-consuming. And the level of accuracy that you get with using binoculars is going to be diminished, especially when you're like this person in the photo here, standing with your neck looking up to the sky for many hours a day. It can get strenuous, and you will have the tendency to maybe miss some things here and there. So, of course, we could also use a man lift or swing staging. These are, of course, going to be logistically more challenging. They're going to cost more money. You need, a certified operator to actually use the equipment, and then someone in the lift that actually can, evaluate or has knowledge of the building enclosure to take down those notes. So, and then, maybe a little less common is the rope access. It's certainly a viable option, but again, you have the logistics of the setup. Certainly safety is a concern here. And obviously the technician or the person using the rope has to have that kind of building envelope or building enclosure knowledge to know what they're looking for. So, the more complex, the more the configuration, the more expensive it is. And obviously this is building by building, but these are all examples of where a drone might be able to kind of fill in instead. And then this is just kind of a graphic of that last slide showing specifically the costs and then the limitations. Again, you have binoculars, which are less expensive, but you're just limited in your ability to actually see and capture images. We have, in rare cases, before drones were really around, we have used helicopters and even cranes with a basket. So, of course, we understand those are options as well. Your drone cost is definitely going to be on the lower end of the spectrum, probably something similar to the binoculars, but logistics and limitations are, way more reduced than these lifts and of course, helicopters. So just as an example, real quick, we were asked to evaluate the slate roofing and also the brick masonry around this clock tower, which is at a town hall. And so you can see, of course, it's really high clock tower. We have, some nice landscaping and pavers around the site. So bringing in a man lift would probably have damaged some of that. You have pretty much, a main road, it looks like, adjacent to it. And, I think even with binoculars, you'd have a tough time seeing the level of detail that you see in the images on the right, which were captured with our drone, in which you can see some really severely deteriorated mortar joints around the clock itself. This is just one snapshot, but of course we found issues with the slate tiles and more issues with the masonry. So, and this was something, we could deploy our drone in just a few minutes, basically standing right on the sidewalk out front and get up to capture these images. So, yeah, I think, this is a really great example. Obviously, trying to use string staging would not have really been feasible here. So either man lift or binoculars would probably be your last two options. So, we said how great the drone is, but of course it does have limitations just like everything else. Primarily is going to be with the FAA and the airspace, which we'll get into a little bit more in the next few slides. Of course, if you have trees or signs, other buildings even that are really close to your building or the area of the building that we're trying to see, the drone's going to struggle. We can't fly into trees or in between branches and things like that. So we do want to have a nice, clear open space around the building ideally. And then weather obviously is probably the most obvious limitation. Everything's electronic on the drone. So any rain or snow is definitely a no-fly zone. Any wind over 20 miles an hour, the drone really struggles just to stay in place. So we'd rather fly on a nice, calm, clear day as well. We need at least 2 miles of visibility. And then, less frequent, but you can have what's called a geomagnetic storm, which is invisible to the human eye, but it can actually interfere with the controls from the remote to the drone. So I think that's only happened to me once in 6 years, but that and satellite coverage, most of our drones work off of geolocation from satellites. So the manufacturers typically recommend a minimum of 12 satellite coverage for those GPS drones. Again, this is really infrequent, but if you might have less than 12, you might just have to wait an hour or two for another satellite to come around, but usually it's not an issue. And then, like I said before, battery life is limited. We have about 20-30 minutes per battery, and that's even less on cold, windy days. But once we take these photos, that's great, but also we need someone to actually go through one by one and review each of these photos once they're back in the office. So, but again, these limitations I think are pretty minor compared to some of the other ones of the other access options that we looked at earlier. So now we'll just, I'll give you guys a quick kind of overview of the FAA regulations and how it regulates us. I'll try not to put you to sleep, but it is something I think everyone should be aware of. So this chart pretty much just represents the difference between flying recreationally and flying for commercial use. So, highlighted on the bottom there is the Title 14 CFR, and we fly under Part 107. So that is actually our, what gives us our license or our certificate to fly the drone. Whereas someone who's just flying for fun doesn't need a license, but they're more limited on where they can fly and when they can fly. And then, we are allowed to fly up to 400 feet above the ground level or above the structure that we are flying around. So that is again limited by the FAA. We'll get into the airspace a little more on the next slide, but there are instances where we can only fly, maybe 100 or 200 feet, depending on our proximity to an airport. So again, you want to keep in mind, these drones that we're using aren't your, Walmart drones that you go and pick up off the shelf. These are, thousands and thousands each with, plus the batteries and things like that. These aren't your, off the shelf drones that you might see in the store. So, so diving in a little bit more to the actual airspace, Gale's based in New England. So I have a map of New England here on the left, and all those little blue circles you see are actually restricted airspaces. And generally, like I said, that happens around airports, no matter how big or small. So, you can see on the right here, we have just kind of a blown up image of Boston's Logan Airport and the restricted airspace around that. So obviously it's kind of just like a giant circle, and then within that circle you have this sort of grid pattern with these different values in each box. And those values actually represent the ceiling height in feet at which we're allowed to fly above the ground. So obviously as you get closer to the airport, you're more like a 0 foot or maybe 100-foot ceiling. 0 foot ceiling just means you can't fly at all. And then, of course, as you move further away from the airport, you start to get closer to that 400-foot number that I mentioned earlier, which is where we're allowed to fly up to anywhere not near an airport. So, if we need to fly somewhere, for example, here, downtown Boston is generally a 0 foot no-fly zone. We just need to go and get a waiver from the FAA and tell them, hey, we need to fly here. We need to fly up to this height above ground level. And then, usually that takes a couple weeks for them to review it and approve it. They can take up to 90 days, but the FAA actually has done a pretty good job, streamlining a lot of this stuff, which I'll mention again later on. And then this is kind of just another image or another view of that airspace. So you see that Class B airspace there, the big yellow shape, which is actually what Logan Airport is a Class B, which is for your larger airports. And you can see it's kind of like that upside down wedding cake shape almost. And anywhere here in yellow would basically be a no-fly zone. So of course, as you move further away from the airport, you're allowed to fly higher. And then further out again, you're allowed to fly even higher, which makes sense, right? And then, you have your lower or your smaller, more, kind of regional or local airports are going to be your Class C and Class D airspaces. Really just depends on the size of the airport and the size of the aircraft that are coming in and out of there. And then everywhere else is pretty much, near the ground level at least, is Class G airspace. So most of the time we're flying in Class G. But, if you are located near an airport, just something to keep in mind, especially for us as we're gearing up to get out there to fly. And then LANC. So LANC was actually enabled back in 2018 by the FAA. Stands for Low Altitude Authorization and Notification Capability. It's basically just a more streamlined way for us to get our waivers. So they've actually came out with a couple of apps that you can get right on your phone. And depending on the airport, if they are LANC enabled, we can just use those apps to get our clearances. And it generally only takes a couple of minutes or maybe a couple hours to get that approval, as opposed to the, like I said, 2 weeks or even up to 90 days as the FAA says that they could take. So it seems like the FAA is really, on board with this. They understand the benefit of drones, and they are really trying to stay involved and stay up to date with a lot of their processes. So, all right. So from there, we'll just take it into some examples of when, we've had the ability to use the drone, and we feel like we've really had good luck and good results with it. This building is actually a hospital way up in Bangor, Maine. So you can see it's, mostly some maybe historic brick masonry, some old slate roofing with, a lot of copper flashing. Really cool building actually, but it was old, of course, and in need of repair. So, the images on the left, you can see A lot of the slate tiles are actually broken. We found some areas where even the underlayment membrane was showing through. So, we were able to get a really clear image of this. This could also be, something the owner wants to address as as it could be a fall hazard to somebody walking below. And, maybe this was an area they were getting leaks, or, an area they were having some kind of issues, air leakage or water leakage. And, we just identified maybe what that problem was for them. And then the image in the top right is actually looks like a piece of a chimney cap is missing, or has maybe broken and fallen through into the chimney. So, this is something you might be tough to even see from the ground, but you can clearly see, again, if they're having leaks here or having issues, we can get right up and see what the issue is, and kind of formulate a repair for them from there. And then in the bottom right, maybe a little less severe, but just a piece of the sheet metal hip flashing on the slate roof has kind of displaced or just shifted down there. So you can actually see the wood beneath it. And again, this could probably be a leak area. So just all things we could really easily identify. Generally, the process for us is to, go around, take some overall photos, like the large photo you see here, and then we'll actually get right up on the building, maybe just a couple of feet from it, and fly and kind of just systematically go around scanning it, taking photos one by one, and then sometimes up to thousands of photos, and then those will be reviewed by someone back in the office for for issues like this. So this was actually an interesting one. This is at a hospital in Boston, Mass. This was a contractor was using a crane to, I believe, hoist a piece of mechanical equipment, and they actually apparently they bumped into the building somehow, and so the owner had reached out to us and said, hey, can you just come out, check the damage, and see what's going on, and so we can kind of send that to our insurance company. So we said, sure. We went out, and you can see, this site, with the congestion of the buildings around it, the limited or very narrow streets that are actually pretty far away from it, this would have been really tough to see with certainly to get a lift in here. Swing staging would have been really difficult with the green roof up above. So the drone was a perfect option for this, and we actually were able to get some really clear images on the right, as you can see, of some of the damage where the that unit hit the metal panels. Here's another example. This is a library. We found some issues with the copper flashing. That photo on the left, where it's looks like it's kind of loose there. It's starting to peel up. And then the image on the right is chimney cap. I don't think there's any issues with the cap itself, but just an example of how we can easily deploy the drone to get up to see something like that. Something like a chimney can be really hard to get to, especially on a slate roof. As soon as you start to walk on it, you can actually create more harm than good. You can start to damage some of the shingles. So the drone is really non-invasive. It's safe. It's relatively inexpensive and non-destructive, of course. Again, just another example of a roof we looked at. This is at a college in Lowell, Mass. So we were asked to look at both the metal panel roof and also the translucent skylight systems. So on the photo on the left, you can kind of see some of the age and wear and tear showing through on the translucent skylights. We were able to look at the flashings. We could get close-up images of the gaskets and the sealants. And image on the right, you can see we're actually able to locate one of the broken snow rails or snow fences that were on that metal panel roof. So, again, could you get a lift up to look at some of this? Sure, but it's going to be extremely difficult, time-consuming, and expensive. Not to mention, if someone was trying to walk up this roof to take pictures with their cell phone or something, it can be dangerous. So this was quick, this was easy, up and down. So really great example. Here's another, sort of historic looking building. We have some brick masonry walls, asphalt shingle roof, and then we also looked at the large cupola that extends out from the roof. So you could see in the top left there, the cupola, where it's showing signs of deteriorated paint, and some of that wood and sheet metal might be starting to need repair. And then on the bottom left there, they actually have a ice dam flashing that you could kind of see some of that hail damage, those little dimples in the flashing. So we could get up close, we could see if any of those dimples were fully punctured through, or was it just kind of a surface dent, and then just sort of an aesthetic thing. We also looked at the asphalt shingles here too. They were in relatively good shape, but again, just another feature, another capability that we can do with the drone. This building's in downtown Boston, and you'll notice, of course, if you were trying to look at these issues from the ground, or you maybe using binoculars, you're only going to be able to see from the ground up, right? You can only look to the underside of a lot of this stuff. So with the drone, what's great is you can actually get a top-down view of some of these pilasters or cornices, and we can usually see more than what you can see from the ground, of course, and certainly with higher quality images. So another good use. And then this one, we did a brick masonry evaluation. This was again at a hospital in Boston, and you can see the images on the top there around the windows. You could really see some deterioration where the steel lintels had actually rusted and were starting to rust jack and cause some pretty severe cracking in the brick and the mortar joints around the windows. And you can see kind of that small roof that goes around this building up there really wouldn't have been very safe for someone to access without being tied off. And so we were able to get up there with the drone, buzz it around, and obviously there's no safety harnesses or anything required for that. And then this is our last one. I just kind of picked this one. I really like this building. It was actually a museum in Charlestown, Mass. And we could see some of the sheet metal flashing certainly starting to pull up, and sort of you can see in the bottom left there, it looks like that whole corner has been peeled off. And then image in the top right, if you kind of really focus, you can see some of the missing slate tiles over there. This building was interesting because it was actually directly across Boston Harbor from Logan Airport. So we were in a no-fly zone for this. And not only that, but this is actually also considered a historic national park. So, drones are also not allowed to be flown in national parks. So we had to get a letter from the National Park Service, send it to the FAA, so that the FAA could approve our waiver to fly here. So even with those limitations, we were still able to pretty easily get around that and get up and get photos for this client. So now that we have the photos, what are we doing with them, right? How are we annotating this? So this is actually a roof plan and an elevation of the building I showed on the last slide. And you can see this one we were asked to look at the slate shingles. So, we use kind of these little, we call them defect bubbles, and they basically call out what the issues are, or if it's, broken slate, loose flashing, and it gives a quantity. So, we can quantify it, we can get it to a contractor to estimate it, and they have this kind of reference with them so that they can see what needs to be done. And then another example, that one was of course using true line work. These ones we actually just used photographs from the drone itself, implemented them right into CAD, and then added our notes and defect bubbles right over the top of that. So this is kind of what our deliverable would look like, along with some kind of written report just outlining what the issues are. And then this photo is just as an example, kind of, this is in progress or during construction photo. So this project actually involves recladding or reskinning this building. This is a housing authority in Cambridge, and you can see it's almost done in this photo, but there is still some roof work going on. Maybe some site work going on. So just another example, we can get out, we can do weekly site visits or construction, progress photos with the drone. Another good use. nobody really even usually notices that it's flying around. So, and with that, I will hand it over to Christoph to talk about some of the infrared technology.
Thank you, Cole, and thanks again for everybody for joining us in this presentation. I will be going over, like Cole mentioned, the infrared thermography as well as some of the 3D capabilities of the drones we use. So next slide, please. So a little bit of science to get us started. What do infrared cameras detect? The infrared is part of the electromagnetic spectrum just above visible light. And what infrared is the process of the acquisition and analysis of thermal information from non-contact thermal imaging devices. So like Cole mentioned, one of our drones has along with the visible camera, a infrared camera. And thermography means writing with heat. So the things we're seeing are either radiation, heat being lost through building components. So just like photography means writing with light, thermography means writing with heat. The picture that is generated is called a thermogram or thermal image, and infrared is what makes it non-contact. So again, we're doing analysis that is non-destructive in terms of looking for either air leaks or moisture penetration. The typical standard procedure for doing infrared analysis is best done at night when outside temps are cooler and surfaces of buildings are not absorbing any heat from the sun. And if there's one law of thermodynamics that you would take away from this presentation, is that warm air or heat energy always flows towards cold. So in the images we will see, anything that's warmer will be a brighter color than cooler objects around it. Next slide, please. So two of the typical ways we do look for thermal anomalies is either through airflow, through seams in a building system, say, connections with roofs and walls, around windows, any other penetrations in the building. And we also look for moisture penetration. So on the diagram on the left, pretty typical where you might see heat loss from a building. Often what we do is we will ask the building managers or owners to either increase the temperature internally inside the building and or boost their HVAC systems so that as the ambient temperature cools down at night, any warm air that's pressurized will be forced out of any leaks. That will just give us a better indication of where we might see air leakage through a building. What we're looking for in moisture penetration, typical roof diagram on the right, the water that must be trapped in the roof insulation. The sun will heat the roof during the day. On a clear night, the roof will cool down by radiation. And because water retains its heat a lot longer, wet insulation cools more slowly than dry insulation. So we will see telltale patterns of moisture penetration even below roof surfaces. Next slide, please. So in this slide, we have a series of case examples, starting with the set of images on the upper left, and we'll work clockwise. The images on the upper left show a wall assembly and a soffit assembly above that with a window system. The images for the infrared images, you will see some air leakage between insulation panels. So the windows show bright because they are warmer, but within the connection to the wall and the roof assembly, you see a slightly warmer line of what would be air coming through that portion. Again, working clockwise to the image in the upper right. This project, we had told the building managers to increase the heat as well as boost their HVAC systems. This was a project where we were testing the recent improvements in insulation and air sealing. And this image shows there were still some air leaks coming from inside the building. Moving down to the image on the lower right, this is a top-down view looking at a roof with some obvious storm damage in the visible image. And then in the infrared image, along with slightly seeing the visible storm damage, that kind of blobulous, brighter orange shape near the edge of the roof is indicative of a moisture penetration. And lastly, the images on the lower left, showing again a moisture penetration or thermal anomaly indicating a moisture penetration. And the person in the visible image is actually marking a pinhole that was discovered in that area. So again, a very useful tool to be able to see anomalies that might not be evident. Next slide, please. Again, like taking visual inspections of buildings, infrared images are verified by thermographers and engineers, and hot, well-defined thermal anomaly locations may indicate trapped moisture or other issues. Each anomaly is interpreted if they will need further evaluation or study by test cuts or more detailed visual inspection. We typically provide a detailed report of the findings that describes the conditions on the day of testing, any anomaly locations, and recommendations for repair. Next slide. Now transitioning into another capability of drones in doing 3D scanning and modeling. As Cole mentioned, we have a couple drones that have this capability where you can set a predetermined flight plan around a building or site, and as the drone flies around, it captures hundreds and thousands of what are point cloud data points, and it also matches the imagery captured to those points where you can build a 3D model. Next slide. So this is just one example of a 3D model we built of the New England Aquarium on the Boston waterfront. Again, a predetermined area of flight coverage was created in the drone software. We launched the drone from the site, and it did its typical flight path that it does, and it creates a rather realistic model of the building. Next slide. This is a complex up in Augusta, Maine. It is a former hospital site that had been abandoned for a number of years. If you look closely at some of the main roof portions of the building, there was a lot of work done to kind of patch areas to keep the buildings from further deteriorating. We've been doing a lot of work on this site, and we've done a 3D model of this entire site as well. Next slide. So with that 3D model, we were able to create elevations because we did not have the luxury of having line drawings. So rather than just use photography, We built elevations from the 3D model after it was scanned, and we did the defecting on these elevations. Next slide. Just like scanning a building, orthomosaics can also scan larger areas. Pretty much the same principle. It flies a predetermined flight plan, gathers all the point cloud data and imagery to make a 3D model of an entire site. This project is a high school in southeastern Massachusetts. A very extensive site plan was built from this. Next slide. From drone imagery, we can also create photo simulations. So the image on the left is an existing condition photograph of a college athletic field. The image on the right makes use of superimposing a 3D model of the proposed track and field and multi-purpose field. That 3D model is matched to the drone photograph, and we were able to showcase what the proposed conditions would be in a rather accurate manner. Next slide. In addition to still imagery, drones obviously can also take video. So this was a project in the town of Harvard, Mass, where they were restoring the roof, along with weekly construction phasing photographs. We did a number of videos, and these videos can be used for marketing purposes and just checking the overall status of a project as well. And that pretty much does it for my portion, and I will hand it back over to Cole. Thank you.
Great, thank you, Christoph. So we'll just finish off here with some of the questions that we get asked a lot just regarding the drone flights. So number one, it's always insurance. So I can't speak for all other services, but at Gale we do have our professional liability insurance covers our drones. We have a supplemental line item for that, and it's pretty much always been sufficient. But you definitely want to make sure that whoever is or whoever you're hiring to do your drone surveys is definitely insured. Safety is always a big one. So we the pilots do perform pre and post flight checklists before every flight. And like I said before, the drones are equipped with onboard sensors. Some even have onboard cameras, so they can even fly indoors instead of the GPS version. So they actually are pretty smart in terms of knowing where not to go. And then again, here at Gale, I can't speak for everyone, but we also include a visual observer, which is just a fancy term for basically another set of eyes, right? Another person to just, they're watching for other aircraft, they're watching the drone to make sure it's not getting too close to, any obstacles. They're making sure people around the site are being, rerouted or just cordoned away from where the drone is flying. And then, we always fly, we always do our best not to fly directly over people. If someone does, walk out of the door underneath where we're flying, we'll just kind of temporarily relocate the drone or land it off to the sides if we need to. And then we are also required to always maintain a visual line of sight. So we can't let the drone out of our sight for any reason. And, for our night flights, we also have to provide additional lights or basically like safety beacons for, just for visual aid, but again, also for obstacle avoidance. So generally very safe. We've never had any issues here. And then some of the owners or building owners that we work with, a lot of them actually are now starting to implement their own drone policies. So it seems like this is also more of a way to monitor or to just track the drone activity on their campus. So, we really haven't had any issues with it. Typically, they just need our drone registration, license information, and they ask that we, of course, respect the privacy of any tenants. And a lot of times, people ask, can you see in my windows, or are you spying on me? Things like that. We rarely can we see into windows with the glare, and even if we can, we're generally there not looking at the window. We're looking next to it, probably around the masonry or the roofing. So, and then it's gone within a few seconds. So, and then if you're thinking about creating your own drone policy, we can certainly, I'm sure your drone provider can help with that, just based on what we've all seen in other areas we've worked at. Like I said, typically it's the drone information, what the actual mission is, and the location, any checklists and insurance requirements as well. So, that's it. I think in conclusion, drones are certainly going to be here to stay. They've, like I said, they've made our lives a lot easier. They've made our clients' lives a lot easier. We can get to hard to reach places really quickly. Like I said, can be deployed within a few minutes, up and down, extremely safe, cost effective. And, this is something we could think about coming out, yearly or annually to review your building, and just keep a good running tab on it. So, yeah, thank you all for listening in. I appreciate your time. And I think we might have a few questions. So we'll give it back to Billy.
Okay. Yes, we definitely have some questions coming in. First question we have is, could we do the measurement in the drone point cloud model?
Yes, so Christoph might be able to answer this better than me, but I do believe the 3D model does have the ability to also take measurements and can create that point cloud with measurements already in it.
Yes, that's correct.
Thank you, gentlemen. Our next question is, despite getting a waiver for the no-fly zones, have you ever had instances where someone reported you or asked what you were doing? If so, how did you deal with those situations?
Yeah, people are usually pretty curious. Generally the visual observer is actually a great person to kind of deflect questions off if we need to. We do ask that building owners also notify their tenants ahead of time, and even local authorities, because a lot of times people will call it in if they think there's something going on. So as long as people are aware, I know not everyone tends to check their messages, but as long as most of your tenants are aware, generally we haven't had any any major issues or anything like that.
Thank you. Our next question is, typically, what height above the roof is optimal for IR roof scans?
I guess I'll take that one. We typically fly anywhere between 50 to 100 feet above the roof. Again, taking in consideration any obstructions around the roof. That we found gives us the best kind of level of detail and not have too much distortion on the lens as well.
Thank you. Our next question is, I find that it is difficult to get out and get approval for flights. It seems like there are a lot of restrictions or roadblocks. How do you best navigate those?
That's a good question. Yeah, I think your main restrictions is going to be the FAA, especially if you're around an airport. And I was kind of saying earlier, they do seem like they're understanding now that drones are becoming more popular, and they're really trying to streamline the whole process. Generally, as long as we have a couple of weeks to get, for us to schedule some time, but also to get our waiver submitted, we really haven't had any issues with them really denying us or us not being able to do the mission because of lack of having a waiver. So I don't know, Christoph, if you had different experience, or?
Yeah, I would say the LANC approval process that you mentioned earlier in the presentation is definitely a nice feature to have. You can get approvals, like Cole said, within a couple hours, maybe a day or two, depending on where you're flying. Some of the zero ceiling clearance locations might take a little bit longer, and it does help if you are flying as a licensed Part 107 drone pilot. You can actually have that information in there's an app that I use on my phone that has that information in there. So the FAA basically has my contact information if should they need to get in touch with me. Also the benefit to that is because the drones work off of satellites and positioning systems, if you try to launch your drone without the FAA approval in a no-fly zone, the drone will not take off because it knows it's in a no-fly zone. So the FAA approval also gives you access to unlock the drone in those areas.
Hey, thank you. Next question is a very interesting one. How do you retrieve stranded or crashed drones?
That's a good one. It's happened. Well, personally, the way that we retrieved it before was we were up in Bangor, Maine, and it landed in probably a 80-foot tall pine tree, and it was about 60 feet in the air. So we ended up calling a tree service to come with one of their mobile, buckets, and the guy went right up and got it, and actually wasn't that bad. But of course, it was a Friday afternoon, and I just wanted to get home. But that's what happened. So, yeah, that's typically probably what we would do. If it's low enough that you can get a ladder out, great. But I guess that would be lucky.
Okay, thank you so much for that.
Sure.
Is there a recommended site to study to get your license?
So I think the course itself is, or I don't know, was there a course? The test itself is proctored by the FAA. So they do produce, I think they have a study guide that goes with it. And so generally you study, you do need to understand, almost the air traffic control concept, not the whole thing, but a little bit about just air traffic control and airspace in general. That's what most of the test is about. And then there's some of the common sense questions, don't fly over people, don't fly out of moving vehicles, but it does take a little bit of effort to kind of learn some of that airspace knowledge, unless you're already, maybe you're familiar with it otherwise, but.
Okay. Well, our next question is, what is your plan for possible legislation regarding American-made drones being the only type used in the future?
Want to take that one?
Oh, well, from what I understand, it would just be a matter of us having to upgrade our fleet to a different drone maker, which is kind of unfortunate, but I kind of guess we'll see what shakes out of that legislation. But there are other drone manufacturers that I guess we would have to investigate in terms of their capabilities and ease of use.
Okay, thank you. Our next question is, have you had uses or are there different processes to use drones for interior spaces to reach difficult areas?
Yeah, so we can fly indoors with our Skydio drone because that's the one that doesn't use GPS for geolocation. It just uses onboard cameras. So it can actually get in really tight with, I think it says within 8 inches or 12 inches of an object, which is crazy. So If we need to fly indoors, we can do that, but we don't need an airspace, waiver or anything like that if we're flying in a building.
Okay. We have a couple more. We have time for a couple more questions here. And one of the questions I'd like to know is, can a certified pilot supervise another person flying a drone?
They can, yeah. So as long as you have a licensed pilot overseeing or supervising, someone who's not licensed can fly under their direct supervision.
Okay, thank you. What is the average time it takes to do an evaluation? Do you need the site to be clear of people?
Depends on the building. I guess if you want to say a standard size building, we can usually get done in a day. And the site doesn't have to be completely clear, but like I said, we can't fly over people, so we do ask that people aren't, kind of around the building. And if they are, we might need to just kind of come up with a new plan, or try to just reroute them if they're on the sidewalk or something like that. But yeah, generally it takes about a day per building.
Okay. Our next question is, what are some of the things you look for in determining whether to do a binocular survey versus a drone survey, such as building attributes, location, etc.?
Yeah, I would say, just overall, is the site congested, or are there a ton of people around that we just can't fly? I think, most of the time now we're certainly opting for the drone, just for ease, and we have those really high quality images for when we get back to the office. But yeah, I guess I would start with the drone, and then if we for some reason can't use the drone, then I would go to binoculars.
The next question is, I am part of a drone team at university, co-op student, and we have a feature on our UAV known as the RTL, Return to Land, function that we use as a flight safety awareness feature. Is there a similar function used on drones?
Yes, so yeah, all our drones have a return to home feature, especially when they get onto low battery. If we let that run out, it'll return home before it runs out of battery.
Okay, thank you. All right, we have time for one more question here. If your drone is under 250 grams, do you need a drone license? If not, how would you get a permit for particular airspace?
I believe if it's under 0.55 pounds, it doesn't need to be registered. If it's over that, it does need to be registered. You don't need a license unless you're flying in a restricted airspace, or if you want to sell your services or your photographs, you need to be licensed. So if you're just flying recreationally, you're really just taking photos for your own, your own use, your own pleasure. But if you want to actually use that as a business, then you need to be licensed.
Okay. And I have a personal question that I would like to ask. Is a hospital with a landing site, is it considered a no-flight zone?
We have flown around helipads, several in Boston with active, med flights. So usually we'll get a radio with the med flight coordinator, and we can just speak directly with them. They can give us a call if they know there's a flight incoming, and we just take the drone down immediately, and we don't take off again until the med flight leaves. So it can be a little challenging if we don't know how long or how often they're coming and going, but it can be done, and we've done it in the past.
Okay. Well, thank you. Well, gentlemen, we are out of time, so I want to thank you. The compliments are coming in left and right for this presentation today, so thank you so much for taking time out of your busy schedule to be with us. And to our attendees, as always, thank you for taking time out of your busy schedule to be with us. So until next time, be safe, stay healthy, and let's really be kind to one another. Thank you so much. Bye-bye now.
Thank you. Bye-bye.